Let's now look at example 6. An automobile battery manufacturer claims that its mid-grade battery has a mean life of 50 months with a standard deviation of 6 months. Suppose the distribution of battery lives of this particular brand is approximately normal. We want to answer two questions. First, on the assumption that the manufacturer's claims are true, we want to find the probability that a randomly selected battery of this type will last less than 48 months. And then secondly, on the same assumption, find the probability that the mean of a random sample of 36 such batteries will be less than 48 months. Now, I want you to notice how these two questions are different from one another. The first one, we only have one battery, which means we're dealing with just plain old X for our battery. And that means we're going to use the z-score that we originally had, X minus the population mean over the standard deviation. On the other hand, in question 2, we have a sample. And because we have that sample, we're dealing with X bar. And we want to use the formula we've been using for all of the examples we've seen thus far in this section. All right, now, what's very important though, as we answer question 1, if we had not been told that this distribution was approximately normal, we could not answer question 1. We need normality in order to use our formula. On the other hand, we would be able to answer question 2, but because of the central limit theorem, which says that as long as our sample size is greater than 30, the sampling distribution of the mean is approximately normally distributed. All right, so that's very important. If we'd not been given this statement, number 1 would not be something we could answer. And you might have a test question asking that very thing, so make note of that. All right, so let's answer question 1 because we do know that our distribution is approximately normal. We're going to use our normal z-score. We have a mean of 50 and a standard deviation of 6, and we want to know what the probability is that this battery will last less than 48 months. So let's fill in, oops, want to go here to z equals 48 minus our mean of 50, and I really need parentheses, divided by our standard deviation, which was 6. So we have negative 2 over 6, which is going to give us negative 0.3333. All right, so I need to go ahead now and look that up using Excel. All right, so we're going to use equal norm.s.dist, negative 0.3333, true, and that probability is 0.3695. Oops, wrong place. All right, now let's answer question 2. Question 2, though, we have a sample size of 36. So let's first note the following. Our mean, so the mean of X bar is our 50 that our population mean was, and then the standard deviation of X bar is our standard deviation of 6 divided by the square root of the sample size. And our sample size was 36. So 6 divided by 6, our standard deviation is 1. All right, so now we have, instead, 48 is the sample mean minus 50, but instead of divided by 6, we want divided by this new standard deviation of 1, and that is going to give us negative 2. So let's look up negative 2. We've got equal norm.s.dist, negative 2 and true, and that makes our probability 0.0228, quite a bit smaller than the other one. And there we have it.